Hello, good morning. All of you, please type in your name. Hello, Atmesh, Vishisht. Atmesh, how is your score? Shreyas, Vaishnavi. Okay, so last class we have discussed a few questions of hydrocarbon, right? So in the same chapter, okay, you got 96.6. Okay, okay, work hard for the coming exam in April. Okay, you have enough time now. You can do much better than this. Okay, so don't lose hope. Right. See, whatever score you get in 96, 97%, 95 percentile, from there, if you can improve at least, 40, 50 marks, you'll be having a good score in JEE mains. Okay, so at least you'll get into good NITs. Okay, so that you can 40, 50 marks you can easily improve in this coming in this the time that you have now, right? So the point is like no the portion where you have where you have where you could not score marks in this particular exam, that portion you have to identify and start working on that. Okay, and again for inorganic I would suggest read NCRT properly every day. Okay, make some plan and read NCRT line by line every day. Okay, and solve some questions. Okay, but they probably ask, most of them they ask directly from NCRT. Okay, so keep that in mind. Anyways, so last class we have discussed few questions of hydrocarbon. Few more we'll discuss today, and then we'll move on to states of matter. Okay. So you see this question. What is the answer for question number 42? Tell me. Aditya is getting B. Why it is B, Aditya? Okay, yes, correct. You see, option B is correct here because of the electron withdrawing nature of this NO2. Okay, so since we have positive charge or carbocation, right? So stability of carbocation in the ring is directly proportional to minus I group, or we can say minus R also, and inversely proportional to, it is plus I and plus R, and inversely proportional to minus I and minus R, right? Electron withdrawing group. So all these NO2 shows electron withdrawing nature. So that will decrease the stability of this positive charge, right? And here we do not have any electron withdrawing group present. So comparatively, B is the most stable compound if we have, right? Suppose if I write down one more example here, if I write down this molecule, right? Here we have positive charge, and here it is suppose C triple bond CH, and all other things are same. H E. Then what is the answer? Suppose this is E, most stable one, right? And most stable compound will have the least energy, right? Tell me the answer now. Okay, what is the answer? C is sp hybridized, more electron withdrawing tendency. It is still B, right? Because it is again, if you compare option B and E, right? Option B and E, this carbon is also sp hybridized, right? This is again electron pulling, right? So again, the answer will be B only. Any electron releasing group, if you add, like suppose in this case, if I add here CH3, right? All other things are same. And if I add here CS3, then the most stable one will be this one, having least energy. Right. So that is how you can do. Okay. So your concept was right. Okay. Next question you see. Which one of the following is most reactive towards ring nitration? Ring nitration. Do you know the formula of this xylene, mesitylene? Okay, so I'll tell you the formula here, right? So xylene or mesitylene is 135 trimethyl benzene. Remember this, okay? 1 comma 3 comma 5 trimethyl benzene, and xylene is 1 comma 3 dimethyl benzene. 1 comma 3 dimethyl benzene. Now you tell me. But you remember these formula. Yes, yes, right. A. Why it is A or why it is D? Tell me the reason. Why B, Ritwik? Na2 has nucleophilic tendency. Aditya, first of all, it is ring nitration. So for nitration, you must remember we use HNO2 and H2SO4, and the electrophile over there is NO2 plus. This NO2 plus attacks on the ring, if you remember. See the correct answer. Yeah, see the correct answer for this question is option B, because it has three methyl group, right? Three electron releasing group, and when NO2 attach, you see you will have a positive charge on the ring. NO2 attach here, and you will have a positive charge on the ring, right? Because a pi bond attacks on this NO2. So this positive charge will get stabilized by the electron releasing group, right? More number of electron releasing group, more will be the stability of this compound, right? So which are following the most reactive towards nitration, since the formation of carbocation is depends on the stability of this carbocation, that this reactivity, and this carbocation in presence of the electron releasing group is most stable. That's why option B, since it contains three electron releasing group, is the most reactive towards nitration. Correct? Option B is right. Yeah, most of you have got the right logic here. So that's the correct answer, option B. So next question, we're moving on. This one. Again, you see, this is a nitration reaction. Where NO2 attach? That's the question. Why it is B? Saundarya, Sanjana, Shreyas. Why it is A? Ritvik and Natmesh. Yes, CF3 is a electron withdrawing group. Okay, CF3 is electron withdrawing group, and it is deactivating group also. Deactivating group, and we can also say it is a meta directing. Meta directing. No, actually, CF3, you must have studied about activation, deactivating group, deactivating group, which groups are ortho-para directing and which groups are meta directing group. Okay, so CF3 is a meta directing group. This information you should have actually. Okay, it deactivates the ring. It is a meta directing deactivating group. So any electrophile in presence of this CF3 group will attack at the meta position of the ring. Okay, that's why we get here option B as the answer. See what happens, any deactivating group or activating group if you have, that will affect the ortho and para position maximum always, right? So if you have activating group present, okay, that activates the ortho and para position, means the electron density at ortho and para position will be more, and hence the molecule will, the electrophile will attack at ortho or para position. Okay, but when you have deactivating group, so that will decreases the electron density at ortho and para position, right? So comparatively the meta position becomes a more electron rich. That's why the electrophile attacks on the meta position, and we call it as meta directing group. Understood? So this thing you must keep in mind. CF3 is deactivating meta writing group. Next question. Just a second, not this one. This is will do. One question I'm not looking at here. Okay. Okay, I'll give you a question here, not this one, but you solve this question first. One question you see this, then we'll move on to states of matter. The percentage of 1 chloro 2 methyl propane 2 methyl propane obtained in the chlorination of isobutane is A, B, this one. See, if there is a compound at meta position, then the reaction will not take place if both meta position is occupied. If one is occupied, then the molecule will attach at the other position. If meta position is occupied, both meta position, then the reaction will not take place. Tell me the answer of this question. Is it B? How it is B? Same here. Okay, Vaishnavi is getting D. Have you solved this kind of question before? Yeah, only two isomers are there, right on the left. This kind of question have you solved before? Yeah, this kind of question actually nowadays they are asking also. Okay, so how do we, you see, how do we solve this kind of question first? Okay, so first of all, you see this the table that I drew here. This one is for primary hydrogen. Okay, this one is for primary. This column. This one is secondary, and this is tertiary, the last one. And here it is the relative rate of hydrogen atom. Actually, it is per hydrogen atom. And this is for chlorine, for Cl2. This value will be for chlorine. Similarly, here also we have the relative rate per hydrogen atom. And this one is for bromine, Br2. Okay. So to solve this kind of question, these relative rate you have to memorize. Correct? So for chlorine, if the hydrogen is primary, the value is 1 for one hydrogen atom. For secondary, it is 3.8, and for tertiary, it is 5. All these are a relative rate per hydrogen atom for chlorine. Similarly, for bromine, it is 1, 82, and 1600. Okay, so first of all, to solve these questions, you have to have these values 1, 3.8, and 5 for chlorine, 1, 82, and 1600. Okay, now you see the molecule that you have is isobutane. Isobutane is this CH3, 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 and one hydrogen here. Okay, so in this molecule, how many 1 degree hydrogen? Can you tell me? How many 1 degree hydrogen we have? How many secondary hydrogen we have? How many tertiary hydrogen we have? Can you tell me? How many 1 degree hydrogen? Is it 9? Correct? 3, 3, and 3. 1 degree hydrogen are 9s on the see 3, 3, and 3. Right? So there are 9 1-degree hydrogen. Do we have any secondary hydrogen? No. 3-degree hydrogen, we have only one. Correct. So now when you try to do the chlorination of this molecule, so what are the two products we get here? One product will be CH3, 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 CH2Cl, and other product will be CH3C, CH3, Cl, CH3. This is the only two products possible, right? So now you see this molecule forms by the reaction of 1-degree hydrogen, and this is formed by the reaction of tertiary 3-degree hydrogen, right? So for this molecule, if you have to find out, the portion or the composition of this molecule, that will be the number of 1-degree hydrogen into its reactivity. Reactivity of what? Reactivity of 1-degree hydrogen, since it is formed by 1-degree hydrogen, right? So it is the composition of this one. So how many 1-degree hydrogen we have? 1-degree hydrogen we have 9. So that will be 9 into reactivity is what? For 1-degree hydrogen, for chlorine reactivity is 1. So 9 into 1 is equals to 1. Similarly, you have to find out the composition of this also. So number of 3-degree hydrogen is what? 1, and its reactivity is 5 for chlorine. So it is 5. Okay. So two molecules we get, A and B. Suppose this one is A and this one is B. Correct? A and B. So the total will be what? A plus B. Right? So percentage of A will be what? A divided by A plus B into 100. That will be equals to percentage of A. Similarly, we can find out percentage of B also, or 100 minus A. So that will be what? A is 9. 9 by 14 into 100. So it will be, you see, it is 450 by 7. So 450 by 7 will be nearly 64% you will get. Is it clear? Understood? So nothing you have to do, just you have to keep this data in mind. 1, 3.8 and 5, 182 and 1600. Mostly maximum time they'll ask for chlorine only. Okay, so at least 1, 3.8 and 5 you must keep in mind. Would you solve one similar question on this? Yeah, you need to keep that in mind, because they will not give you these rates 1, 3.8 and 5. So this you have to memorize with respect to the atoms. I2 they don't ask usually, because the reactivity of iodine is very less. We need some oxidizing agent for iodination, right? For iodination we need some oxidizing agent. What are those oxidizing agent? HNO3 and iodic acid HiO4. So generally, iodination is very difficult. Is a bit difficult procedure. So we don't do iodination. So mostly they'll ask chlorine only. But I'm giving you one more here. That is bromine. You can find out B also. The question was this only. 1 chloro 2 methyl propane. So 1 chloro 2 methyl propane is this only, Ritvik. You see, they haven't asked about this. Yes, right. They ask about 8A only. You see the questions. Any doubt you have? Do you want to solve one similar question on this just for practice? Yes. Okay. One more question. So, question you see, you need to find out the percentage yield of call me once each. Okay. So you need to find out the percentage yield of monochlorinated product in the chlorination of butane. Tell me the answer. See, actually, chlorination, Saundarya, chlorination of alkane. What kind of mechanism it shows? Can you tell me? It is free radical mechanism. Yes. And free radical mechanism, the stability order is what? 3 degree maximum, then 2 degree, and then 1 degree. Yeah, right. So what is the stability order of free radical? Maximum for 3 degree, then 2 degree, then 1 degree. That's why the reactivity of tertiary is maximum here. Clear? Tell me the answer to this question. You don't have school Niranjan today. Is it 33.33? Can you give me the exact value? Visist assignment. Oh, you have physics class today, Niranjan, right? What time you have physics class, Niranjan? Okay, you see here. Butane is this CH3, CH2, CH2, CH3. So number of primary hydrogen is 6 and secondary hydrogen is 4. There is no tertiary hydrogen here. 28.3. That's correct, Simon. That's the exact answer you get. Okay. So you get basically you get here. See, the answer of this is there are two answers of this. Okay, both you have to write. One will not give you the answer, marks, right? Because try to understand the question. Yield of monochlorinated product. So first of all, you have to find out that how many monochlorinated product we get. You understand this? So how many monochlorinated product we get into this? How many monochlorinated product we get here? Two, right? So there are two monochlorinated product we get. So we have to find out the percentage composition of both, not just one. Right? So one will be suppose X, so other will be 100 minus X. That's the thing, right? So why it is two? Because we have two different position. One is this, either the chlorine will attach on this carbon or on this carbon. But this two carbon are having the equivalent position, and these two carbon is again the same position we have, right? So there are two possibility we have. So one will get when the 1 degree hydrogen takes part in the reaction, then the product will be this CH2Cl. And the other product we get when secondary hydrogen takes part in the reaction, CH2CH3. So now the composition of this, if you have to find out, we again use the same data that we have done in the earlier question. So since it formed by 1 degree hydrogen, so reactivity of 1 degree into number of 1 degree hydrogen, that will be for 1 degree it is 1 and number of 1 degree hydrogen is 6, so that is equals to 6. And for this one, number reactivity of secondary hydrogen is 3.8 into 4, that gives you 14.3. So the percentage of this will be 6 divided by 6 plus 14.3 into 100, and this comes around, it is 15.2, right? Sorry, it is 15.2. It is 15.2. So 6 plus 15.2. So when you solve this, you will get 28.3%. Right? It is 28.3%. And then the 100 minus this will be the composition of this product. Right? So that is how we solve this kind of question. Okay, generally they ask you the chlorination only. They won't ask you, the bromination of the molecule. Correct. So if you remember for chlorine, you can do the questions, but the bromine one is not that tough. Also 182 and 1600. Okay. So that's the two things you have to keep in mind. Then you can solve this kind of question. Is it clear? Understood? They haven't asked this type of question in this JEE main exam. Okay. So try to figure out this thing also, that in one particular chapter what kind of question they did not ask. Okay. Okay. So now we are moving on to the next chapter, that is states of matter. Solve this one. All of you are getting C. Correct. Option C is right, since all of you are getting. So I'm not going to solve this question. If you have any doubt, you can ask me, then I'll solve this. Otherwise, I'll move on. Okay, I'll move on then. Option C is correct. What about this question? The first one is this. I'll tell you. It's the pressure at constant volume. All of you are getting A. I think this should be PV only. PV versus V. It should be PV versus V. Okay, option A is correct here. It is clear. This is obviously P 1 and 1 by V, right? So B is 3. B is 3, we have only one option. A is correct. Right? This is the graph of pressure and volume. So A is 2. A is 2. This is the graph of PV versus V. Next question you see. All of you are getting D. Atnesh is getting C. Okay. See, equal weights we have. So for number of moles of ethane will be what? Suppose the mass we are assuming m divided by molecular mass of this, which is 30. Similarly, the number of moles of hydrogen will be m divided by 2. So mole fraction of hydrogen, that will be equals to m divided by 2, m by 30 plus m by 2. So this you have to solve, and you will get 15 plus 1, 16, and then 15. So we'll get 15 by 16 here, right? And we know the partial pressure of hydrogen will be what? Mole fraction of hydrogen into total pressure. That will be partial pressure of hydrogen will be equals to what? 15 by 16 into PT. So the 15 by 16, the fraction of total pressure we have, right? That's why the answer is option D. Okay. Next question. What happened? Tell me the answer. Okay. D is the correct answer. Option D is right. You see, how do we do this? What is the volume of, suppose the volume of mixture, I assume, volume of mixture is 100, right? So what we can write, the total mass of the mixture is equals to what? The mass of N2O4 plus the mass of NO2. Mass of the mixture will be what? The density of the mixture into volume, which is 100, right? And that will be equals to the density or vapor density of N2O4 into its volume plus the density of NO2 into its volume, right? This we have to find out. Now, what all data are here that we have to see? Volume of N2O4, NO2, we can find it out. Vapor density or density also we can find out, since we know the molecular mass of these two elements, molecules, right? So you see here, the volume of N2O4, if I ask you, what is this? Can I write this 2 by 3 into 100? Ratio is given since, so 200 by 3. Similarly, volume of NO2 is 100 by 3. Okay. Now, since molecular mass of N2O4 is given, is we know the density of N2O4 will be what? Molecular mass, that is 96. 92, sorry. 92 divided by 2, which is 46. And the density of NO2 is 46 is the molar mass, divided by 2 is 23. All these value will substitute here and we'll find out density of the mixture. So density of the mixture will be density of N2O4, 46 into 200 by 3 plus 23 into 100 by 3. This divided by 100. So 100 gets cancelled. So it is 92 by 3 plus 23 by 3. 115 by 3. That will be 38.3 you'll get. Okay. One more thing you can observe here. Density of the mixture, we can also write directly that the density of NO2 plus density of N2O4 divided by the total NO2 and N2O4 that you have, which is 3 here in this case. If this NO2 and N2O4 is mixed in A is to B ratio, then we should write here A plus B. If the ratio of N2O4 and NO2 is A is to B by volume. In this kind of question, they always give the ratio in volume only. Otherwise, it is very difficult to form. You should have then some other data also. This you must keep in mind, right? And we know this also, NO2 and N2O4. Molecular mass we know, so we'll know the density also that we can directly use here. Right? So option D is right. Next question you see. Vaishnavi, Saim here, Atmesh is getting A, Purvi is also getting A, Aditya is getting B. A is the right answer. Aditya, cross check your calculation. See, the question is the option is 81.1 centimeter from NH3. Did you get it from NH3 or HCl, Aditya? Okay. This is HCl and this is NH3. All of you have got answer A. A is the correct one. And this is NH3. Suppose I assume from A distance from this HCl end, we'll get the white fume over here. Right? This should be obviously 200 minus A because it is given 200 centimeter. So we'll directly write here rate of diffusion of HCl, R of HCl divided by R of NH3. That will be equals to the molar mass of NH3 divided by molar mass of HCl, root over of it. And rate is equals to what? Distance travel divided by time. So for HCl it is A by T. For NH3 it is 200 minus A by T is equals to molar mass of NH3 is 17. For HCl it is 36.5. This is what you have to solve and you will get A because T and T gets cancelled. So A value will be 81.1 centimeter from this HCl side. Hence option A is correct. Next question you see 46, which is the sixth question. A mixture of NH3 and N2H4 is placed in a sealed container. Okay, this is sealed container at 300 Kelvin. The total pressure is 0.5 atm. When the container is heated to 1200 Kelvin, the both substance decomposes completely according to the equation. According to the equation, after decomposition, the total pressure at 1200 Kelvin is found to be 4.5. 1200 Kelvin is found to be 4.5 atmospheric. What is the percentage of N2H4 gas in the original volume in the original mixture, assuming ideal behavior? Is it C? D? What about others? Tell me the answer. Okay. You see, for this question, option D is correct. Option D is right. You see here, first of all, we have to find out the percentage of N2H4 in the original mixture, right? So in the original mixture, we do not know the number of moles of N2H4 and NH3. So what we assume, N1 is the number of moles of N2H4 initially, and N2 is the number of moles of NH3 initially. All these data are in the initial condition. So according to the question, what we have to find out? We have to find out N1 by N1 plus N2 into 100. This is what we have to find out. So either we'll get N1 and N2, then we'll find this, or directly if you can get the value of this expression N1 by N1 plus N2, then also we can get the answer. Okay. Now this is the question we have. Now coming back to this question, both the molecule dissociates according to this reaction. You see, from the first reaction, what we can say that 2 moles of NH3 gives 4 moles of product. Total I am talking about. And in this 4 moles, we have 3 moles of H2 and 1 moles of N2. But 2 gives 4. That is what is required here. And 1 mole of N2H4 gives 3 moles of product. Right? So since 2 moles gives 4, so what is the number of moles we have assumed here? And for NH3 it is N2. So N2 moles gives 4 N2. Sorry, N2 moles gives 2 N2. 2 gives 4, 1 gives 2, N2 gives 2 N2. 1 gives 3. So N1 gives 3 N3. Right? This is the final number of moles we have. No, this is the number of moles we have for N2, what we say, sorry, 2 moles of NH3 is N2, no, so this is N1, sorry. This is N1, 3 N1, right? This is the number of moles of product that we get from the first reaction and the second reaction, correct? So now we can apply, since the molecule follows ideal gas behavior, so we can apply PV is equals to nRT. So in initial condition, what we can write, you see, pressure into volume is equals to nRT, correct? So pressure is given 0.5 atmospheric. So 0.5 into V is equals to N1 plus N2 into RT. The total number of moles initially is N1 plus N2 only. When it dissociates, the pressure becomes 4.5. Right, it is given in the question. 4.5 into volume is V. The number of moles will be 3N1 plus 2N2 RT. Now, when you take the ratio of these two, okay, I'll take this is 1 and this is 2. So to simplify the things, I'll take 2 by 1. So it is 3N1 plus 2N2 divided by N1 plus N2 is equals to what should we write? Okay, we have different temperature, no? So we have 300 and 400. So it is T1 and T2 I should write. So this by this is equals to 4 by 9. 2 by 1. So it is 9 by 4. Only you need to solve this. Now you see what we can do next here. Since n1 plus n2 we have here, and we have to find out n1 by n1 plus n2. So I'll write this 3n1 as 2 n1 plus n2 plus n1 divided by n1 plus n2 is equals to 9 by 4. When I divide this here, so you'll get 2 plus n1 divided by n1 plus n2 is equals to 9 by 4. From this, n1 divided by n1 plus n2 is equals to 1 by 4, which is nothing but 25%. That's why option D is correct. Okay, so like this you can solve, your calculation will be a bit easier. Or you can find out n1 plus n2, solve the equation, you'll get n1 plus n2, and then you will again find out n1 by n plus n2. Right? Any doubt you have in this one? Question number 7. Done. Shreyas is getting A. So Andrea is getting C. Tell me the answer, others. Urvik Meher is getting A. Atmesh is also getting A. Right. You see, option A is correct here in this question. Now you see, how do we solve this question? First of all, in the question it is given at STP, this gram of O2 diffused through a porous partition in this second. What volume of CO2 diffuse in the same time under the same condition? So what we can write, the rate of diffusion of O2 divided by the rate of diffusion of CO2 is equals to the molecular mass of CO2 divided by the molecular mass of O2 root over of it, which is nothing but 44 by 32 root under, right? And rate also we can write what? The volume of O2 diffused divided by the time which is given here. This divided by volume of CO2 diffused divided by the time. And this will be equals to 44 by 32 root under. So we have to find out, since time is given, excuse me, time is given which is 1200, right? And this is same for both the gases, right? So we can easily, excuse me, eliminate the time here, correct? Volume of CO2 we have to find out. So if you know the volume of O2, we can find out this, right? So mass of O2 is given. Mass of O2 is given, which is 0.48 gram. So we can find out the volume here because it is at STP, right? So we know at STP, it is given at STP. At STP, 32 gram of oxygen, which is 1 mole, 32 gram of oxygen is equals to 22,400 ml volume. 1 mole is equals to 22.4 liter. So this many ml. So what is the mass we have here? 0.48 gram. So volume will be 22,400 into 0.48 divided by 32. So when you solve this, you'll get the volume as 336 ml. This volume will substitute here. 336 divided by volume of CO2 is equals to 44 by 32 root over of it. So volume of CO2, when you solve this, you'll get 286.5 ml. Okay. See, one more thing I would like to tell you here. You see the volume of CO2 that you are calculating. If you're getting any doubt into this, you see it is 336 into this by this is what? 8 by 11 root under. So obviously this value is what? It is less than 1. Right? First of all, this value will be less than 1. So the volume of CO2 should be less than 336. Correct? So you cannot get this as an answer, option B, right? And this is less than 1, but it is not that much small also, so that you can get this 112.2. Correct. So these two options you can eliminate easily. You will have doubt in A and D, and for that you can calculate this, and then you can understand. Understood? So like this you can eliminate a few options also and avoid a little bit of calculation here. Understood? Next question you see. All of you are getting B. Okay, yeah, option B is correct. Can I move on, or do you want me to solve this? Yeah, B is right. So all of you have got the answer, so I'll move on, right? Okay. See the next question. This one. Yeah, it is dihydrogen fluoride and NH3, right? So it depends on the diffusion of gas. So which the gas which has the lower molecular mass will diffuse faster, right? And the ammonium chloride ring forms near that particular gas, end of that particular gas. So since the molecular mass of HCl is more than to that of NH3, right? So hence the diffusion of this will be higher. Diffusion rate is more, and hence this ring forms near this NH3 gas, end of this NH3 bottle, right? So answer will be option C. Okay, yeah, fine, fine. Diffusion rate of this is more, so the uh, ring forms near the hydrochloride gas. Okay, so this one is fine. Hydrogen chloride bottle. NH3 will diffuse more, so the ring forms near the end of HCl. Yeah, right, right. So diffusion of NH3 is more, so NH3 will travel more distance, so ring forms near HCl end. That's what it's correct. Option B is right. Correct? Right? Okay. 10, 11. 10th one, A is correct. 11th, you tell me. Eleventh one, all of you are getting A. A is also correct here. If you have doubt, you tell me, I'll just do this. Otherwise, I'll move on. Let me know. Do I need to solve this 11th one? Okay, I'll do this. See, E is the kinetic energy and U is the RMS velocity. The URMS we know, or VRMS if I write, it is equals to root over of 3 PV by M. Okay, and we also know this PV is equals to KT for N is equals to 1 for one molecule, where K is the Boltzmann constant. This Boltzmann constant is nothing but R by Na. R is the gas constant here, right? And kinetic energy formula, which is nothing but E, is equals to 3 by 2 kT, PV or kT, right? 3 by 2 kT. So kinetic energy or kT value, if I find out from here, that will be 2E divided by 3, right? So this is the value of kT or PV, we can write this. And this I am going to substitute it here. So VRMS is equals to 2E by M root over of it. Hence option A is correct. Right? Option A is correct. Understood? 12 and 13. Excuse me. Why it is B? Niranjan, how it is D? Yes, kinetic energy depends only on temperature, correct? And it does not depend on any other factors, right? So when the temperature is same, the kinetic energy of the molecules, gaseous molecules are same as that of hydrogen molecule. Got it, Niranjan? Question number 13. Thirteen is also B. Option B is right. Kinetic energy is directly proportional to the root over of temperature by molecular mass. This is what you have to use. You'll get the temperature for SO2 because molecular mass you already know. Okay, 13th one, B is correct. Next one. Yeah, it is same as the previous question, right? So again, option C is correct. Kinetic energy is directly proportional to temperature. Right? So kinetic energy at 40 degrees Celsius means 313 Kelvin divided by kinetic energy at 20 degrees Celsius means 293 Kelvin will be equals to 313 by 293. Option C is correct. 16th one. It's a direct question. Okay, you must have seen this question at many different books. The order of these speeds are what? We have R, A, M. R is for root mean square, A is for average, and M is the most probable speed. Right? So root mean square should have the maximum value. If you remember this order, you can easily say option B is correct over here. Root mean square will have maximum value and most probable will have minimum. Option B is correct. Solve this one. In question number 14, just a second, I'll check. What happened in 14? Question number 14, you see the first one here. VRMS of H2 divided by VRMS of O2. That will be equals to temperature of by molecular mass divided by temperature by molecular mass. This is for O2 and this is for H2, root over of it. Right? So H2 is at 50 Kelvin. So we'll write 50 here divided by temperature of O2 is 800. Molecular mass of O2 is 32 and that of H2 is 2 root over of it. Okay, so this will get cancelled by 16 and it says 1 only. So it's 1 only, Purvik, you see. We'll get it 1. That's what I have done, you see. Okay, so see, option C is correct. Next question, you see. What about question number 20? You did not solve question number 20. Tell me 20 first. 21 is right. Compressibility factor is less than 1. So molar volume is also less than 22.4 liters. Correct. Sanjana is getting D. Question number 20. Question number 20. Have you finished? See, the value of critical pressure and temperature. We know Z at critical condition is equals to what? PC VC divided by RTC. Okay, this is the value of Z. So PC is equals to what at critical condition? It is A by 27 B square. VC is equals to 3B and TC is equals to 8A by 27 RB. If you substitute these values, you are getting 3 and 8 here. So the answer you'll get here is 3 by 8. Right? Now you solve question number 22. We'll take a break after this. Done. Question number 22. Do that. Vaishnavi, Sanjana. 22, you are getting D. Niranjan, what is the mass you are getting? Molecular mass? Or simply you said since sulfur is there, so it should be acid. See, in this type of question, when you have to find out the molecular mass, correct? So we know one atom, the mass of one atom of that particular element. So here it is sulfur. So one atom of sulfur, the mass is 32 gram, right? If you have the value of molecular mass, if we find out, then we can find out the number of atoms present in this sample, right? That is molecular mass divided by 32, right? Suppose the molecular mass you are getting X. So number of sulfur atom is what? Number of sulfur atom is equals to 32, sorry, X divided by 32. And suppose it is N or Y. So molecular formula will be what? SY. That is the answer. So point is what? We have to find out Y, right? We have to find out this value Y. And for that, we need to find out the molecular mass, right? So here, see what all data are given. Mass of sulfur is given. It is 3.2 gram. Molecular mass is not given. I'll assume M. Temperature is given 450 degrees Celsius. So it is 450. So it is 450 plus 273 is equal to 723 Kelvin. Pressure is 723 mm of Hg. So this divided by 760 atm. Volume is also given, that is 780 ml. So 780 divided by 1000, it is liter. So we can apply this PV is equals to nRT because as vapor we have here. So PV is equals to nRT. So you see pressure, we have to find out this molecular mass, and we can write mass divided by molecular mass. So molecular mass is equals to what? MRT, which is 3.2. R value is 0.0821. Temperature is 723. MRT divided by PV. Pressure is 723 into 760. Volume is 780 into 1000. This is what you have to solve. I have converted into ATM so that we can get the mass in gram. Yeah, that also you can use. So molecular mass, when you solve this will get cancelled. Right, and you will get here because this you have to solve. Whatever calculation you have to do this. So when you solve this, you'll get molecular mass is 256 gram. So the value of Y will be what? It is 256 divided by 32. That will be 8. Hence the molecular formula is S8. Option D is right. Understood this? Right? Got it? All of you. Okay, so we'll take a break now. We'll start at 11:35. Okay? Okay, so we'll resume the class at 11:35. Take a break. Okay, can we start the class? Yeah. Next question you see. Solve this 23rd, 24th. Okay, tell me the answer for 24th one, 23rd one I'll solve. What is the answer of 24th? Tell me first. 23rd I'll solve. The given, okay, I'll see this 24th one. The given graph represents the variation of Z versus P for three gases A, B, and C. Identify the only correct statement. Okay, so there are two possibilities we have here. There are three possibilities actually. One is Z can be greater than 1, Z can be less than 1. Right? It is greater than 1 when A is equals to 0, or it is less than 1 when B is equals to 0. We can derive this also from the van der Waals equation. We can derive this. So what happens here? This A will be equals to 0 when there is no interaction, and this B will be equals to 0 when there is decrease in pressure. Right? So Z will be less than 1, Z will be greater than 1, the condition is this we have, and Z is less than 1, the condition is this we have. So you see option A, for gas A is equals to 0, and this dependence on P is linear at all pressure. Okay, so for A is equals to 0, you see we'll get Z greater than 1. We can derive this also. You see, the van der Waals equation is this: P plus A by V square into V minus B is equals to RT. When A is equals to 0, so we can eliminate this when there is no intermolecular force. We can eliminate this with respect to this, so we get P into V minus B is equals to RT. When you solve this, you'll get Z is greater than 1. Right? So the compressibility factor should be greater than 1 when we are assuming there is no intermolecular attraction. That means A is equals to 0. So right, A option is correct here. For gas A, Z is increasing when small a is equals to 0. Now, we have to find out the incorrect statement. For gas B, when B is equals to 0, its dependence on P is linear at all temperature. That is also true. Linear at all temperature. So B option is also true. For the gas C, which is a typical real gas, for which neither A or B is equals to 0, by knowing the minima and the point of intersection with that is equals to 1, A and B can be calculated. We cannot calculate this A and B because it depends on what? It depends on the gas, what gas we are using. A value and B value depends on the gas that we have here. Right? By this graph, we cannot calculate this A and B value. Right? So this is one thing. So this option, I think it is wrong. At high pressure, the slope is positive for all real gas. That is also true. Pressure keeps on increasing and slope is always positive. And slope is also, D option is also true, right? So C option, you see, it is A and B we cannot calculate from this graph. Hence, C is wrong. The answer will be option C. The graph C represents real gas. Okay. You see, when pressure is high, the real gas starts behaving as an ideal gas. You see, at high pressure, the slope is positive we are getting. It's true. Option D. Is it clear? Understood? Question number 23rd, you see. What is the difference in the density of dry air at 1 atmosphere at 25 degrees Celsius, right, and moist air? So first of all, we'll find out the density of dry air. What is the molecular mass of dry air? MD is for dry air, right? That will be, since the air contains what? Mainly oxygen and nitrogen, right? Air contains mainly oxygen and nitrogen, and it is given in dry air. The composition is given, you see here. So what we can write, you see, molecular mass of dry air is equals to the molecular mass of oxygen, that is 32, into its percentage composition, 24.5 given in the question, plus for nitrogen 28 into its percentage composition, 75.5, divided by total we are assuming as 100. This when you solve, you will get 28.98 molecular mass of the dry air, gram per mole. So density of dry air will be what? Pressure into molecular mass divided by RT. Formula of density, we have this only. So pressure it is given 1. Molecular mass we have calculated 28.98. divided by R value is 0.0821 into temperature is 298, 25 degrees Celsius is 298. And this gives you approximately 1.184. 1.184 density. So this is the density of dry air. Now for this moist air, you see relative humidity is given. So the formula of relative humidity is what? RH. The formula is the partial pressure of H2O in air divided by the vapor pressure of H2O. Vapor pressure of H2O. Right? Partial pressure by vapor pressure. Relative humidity is given, it is 50%. And vapor pressure is also given, 23.7 torr. Right? So when you solve this, you'll get the partial pressure of H2O. And that will be 50% relative humidity 0.50 into vapor pressure of H2O is 23.7 it is given divided by 760. So this becomes atmospheric. So this value you will get 0.0156 atm pressure of H2O is this, right? Now the percentage of H2O vapor, it is a vapor pressure of H2O, right? The percentage of H2O vapor will be what? Percentage of H2O vapor in air. That will be the pressure of H2O into 100 divided by the total pressure we have, or atmospheric pressure we have 1, which is equals to 1.56%. Now this is the value of H2O vapor present in air apart from oxygen and nitrogen, right? So what we can write, the percentage of N2 and O2 will be what? That will be 100 minus 0.156. See, moist air, what happens? We have a little bit of dry air. If you have, we assume that there is no water content, there is no moisture into that. But when you have moist air, so some water also converted into vapor. So apart from N2 and O2, we'll have water vapor also. So we have calculated water vapor, the percentage of water vapor present. 100 minus that gives you the percentage of N2 and O2. So that will be 98.44%. Now the molecular mass of wet air will be what? That will be equals to 28.98, right? 28.98 into 98.44 plus the water vapor we have there. Molecular mass of that will be 18 into 1.56. Right? This is nothing but the molecular mass of dry air here. This into the percentage composition of N2 and O2, because dry air contains what? Nitrogen and oxygen. So the mass of dry air into the percentage of that. That's why I have taken this. This whole divided by 100 again I'll take, because the mixture is 100 only. So when you solve this, you'll get 28.81 molecular mass of wet air. Right. Now you see, similarly, like we have calculated the density of dry air, We will also calculate here the density of wet air, because the molecular mass we have, that is the task we have in this question. We have to calculate the molecular mass of dry air and wet air. After that, it's fine, density formula we'll use. Okay, so you see the density of wet air will be what? Again, P mw divided by RT. That will be equals to, when you substitute all the term here, 1 into 28.81 divided by 0.0821 into 298, that this gives you 1.177. So the difference here, it is what? 1.184 minus 1.177, and this value gives you 0.007 approximately. So answer will be option B. So I'll explain this thing again. The objective is to find out the density of dry air and wet air. Correct? Difference we can find out. And density formula we know, that is Pm by RT. Density formula we already know, that is Pm by RT, where M is the molecular mass. So if you are calculating the density of dry air, molecular mass will be of dry air. For wet air, this will be for wet air. So our objective is to find out what is the molecular mass of dry air and wet air, both. Correct, Ranjan. What is the molecular mass of dry air and wet air, both? So for dry air, you see, we know the composition of N2 and O2. First of all, in dry air, we have nitrogen and oxygen only, we'll assume. This is also given in the question. So the molecular mass of N2 into its composition plus molecular mass of O2 into its composition will give you the molecular mass of dry air is 28.98. Right? This value will substitute here. You'll get the density of dry air. Now for moist air, the term relative humidity is given. And this formula you should know for relative humidity. The partial pressure of water in air divided by the vapor pressure of H2O. This is the formula of relative humidity. Right? So vapor pressure of H2O also it is given in the question. So we'll find out partial pressure of H2O. Why we need partial pressure of H2O? Because this is the pressure. So when we find out the H2O vapor in, that will be what? Partial pressure into total 100 we have divided by the atmospheric pressure, which is 1 atmospheric, right? So the percentage composition of H2O in vapor into its pressure, that is atmospheric pressure, is equals to the total amount we are assuming 100 into its partial pressure. Correct? So we'll find out the percentage of H2O vapor in air, that is this. So now in the air, apart from nitrogen and oxygen, we'll have what? We'll have water also, water vapor also. And that composition we have. So 100 minus this gives you the percentage of nitrogen. Correct? Now this is the percentage of nitrogen into the molecular mass of dry air, which is nothing but 28.98, plus the molecular mass of H2O into its composition by 100. This gives you the molecular mass of what? Molecular mass of wet air. Now, again, we'll use this formula and we'll find out the density of wet air and we get the difference. Did you understand this? So this is a different type of question we have. Generally, they don't ask this relative humidity question and all, but this formula you must remember. Okay, because this time I'm trying to we have already done a set of questions in the previous problem solving session. Now, since you have exams, we don't know what question they are going to ask. So I'm trying to cover up all those different types of question that is possible in one particular chapter, right? So this is a different types of question. We must remember these two formula, relative humidity and all. Okay, just a second. Hello, hello, hello. Yeah. Next question you see. Tell me fast. C is correct. Next one you tell me. 26th. The temperature at which the vapor pressure of a liquid is equal to external pressure is called boiling temperature. A is correct. At high altitude, atmospheric pressure is high. Wrong. So A is correct. R is false. Option C is right. Right? All of you have done this. Next question you see. This one, 27th and 28th. Twenty-seventh. 'See, the water vapor density is given, right? 0.0006 gram per centimeter cube. When you multiply, since volume occupied by water molecule in 1 liter, right? So mass of 1 liter of steam, if you take, right? So 1 liter of steam you have here. So this into 1000 ml, nothing but 1 liter, is equals to 0.6 gram of water centimeter cube. 0.6 gram of water we have. This is the mass of 1 liter steam, which is nothing but the mass of the liquid water. Correct? So mass of 1 liter steam is this. density is given 1 gram per centimeter cube. This, see, the amount of steam formed, that will be equals to the amount of water or liquid water vaporized. Correct. So mass of the steam is equals to the mass of the water. Correct. So mass of the water is also 0.6 gram. Volume is density is given. So volume is what? Volume of water is equals to 0.6 into 1, that is 0.6 gram per centimeter cube. The same volume is occupied. So answer will be option C. Right? 28th one. We'll balance the charge here simply. Right? So you see the metal oxide is M 0.980, and in this we have M2 plus and M3 plus also. So suppose that 3 plus we have to find out, so we'll assume this as X. So this will be 0.98 minus X. So total charge will be what? Here it is 3x and here it is 0.98 minus x into 2. This plus the charge on oxygen is minus 2 is equals to 0 because the oxide as a whole is neutral. This is neutral. So total charge, and my total charge on this metal is this, plus charge on oxygen is minus 2 is equals to 0. So when you solve this x, you will get 0.04. So percentage will be what? 0.04 divided by 0.98 into 100, which is nothing but 4.08 percentage. Right? Last two questions. Solve these two. Twenty-eighth, 29th one is based on which concept? Yeah, it's Bragg's law. So what is the formula of Bragg's law that you apply simply? All data are given, you will find out the wavelength. The formula we have here is n lambda is equals to 2d sine theta. N is given first order diffraction 1. Set of crystal phase at an angle of 11.8. So theta is 11.8 degree. These values are not given in the question. It should be given. D is what? 0.281 nanometers. So 0.281 into 10 to the power minus 9 meter. All these value you will put, and you'll get lambda is equals to 0.1149 nanometer. This is the answer. Only substitution and calculation you have there. Yeah, it's C. Done. You can use calculator to get sine value, sine 11.8. That's not an issue. If they ask this question in the exam, they'll give you the value of sine theta. Don't worry with that. They'll give you this value, Niranjan, in this exam. Don't worry with that. Done. Last question for today, question number 30. Solve this. How many unit cells are present in a cube-shaped ideal crystal of NaCl? No, B is not correct. See, the mass of one unit cell, if I ask you, the mass of one unit cell is equals to the volume of one unit cell into its density. Density, we know volume is A cube, where A is the edge length. Density is what? Z into M divided by AQ into NA, Avogadro number. AQ gets cancelled. Mass of one unit cell is Zm by Na. NaCl it is given. So NaCl we know it forms FCC lattice. So Z value is 4 for that. Mass, we also have molecular mass of NaCl 58.5. Na is 6.022, 10 to the power 23. This will be equals to, when you solve this, 38.87 into 10 to the power minus 23 gram. Right? So now you see, this is the mass of one unit cell, right? So 38.87 into 10 to the power minus 23 gram is equivalent to one unit cell. We have to find out the number of unit cell in 1 gram. So in 1 gram, the number of unit cell will be what? 1 divided by 38.87 into 10 to the power minus 23. So when you solve this, the answer you'll get is 2.57 into 10 to the power 20. So it's A. Did you understand this? Correct? Got it? It is NaCl, so FCC, so Z must be 4. Okay, so we'll wind up the class here only. Okay, next class we'll solve some other topic, right? So the class schedule, and that will be probably on Friday. I will let you know. Correct? Thank you all. NCRT you must read for inorganic chemistry. I'm telling you again and again. Okay? Try to finish NCRT at least 2 times in this 2 months. Okay? So thank you all. Bye.